Okay, so in this video we will go over practice 2 for 7.1, adding and subtracting polynomials. So the first thing you want to do is look at the highest exponent. In this case it's a 3, and then here is the highest exponent of a 2. Once you do that, the highest exponent of a 3, degree 3, is actually called a cubic. And then a highest exponent of 2 is called a quadratic. Then the next thing that you want to do is look at the terms. We have one term, we have two terms. So we call that a binomial, bi for bicycle. You want to put cubic and then binomial. And then you want to look at this. We have one term, two terms, then three terms. 3 means trinomial means terms, so we have 3 terms. Once we go over to slide 3, we have just the degrees. Okay, degree is what we look at for the exponents. So we look at the biggest exponent. So we have squared, we have a number next to the x. Let me see if I can write this. Here's a 1, here's the exponent, the highest, that's a 2, highest exponent, a 3. There is no variable with an exponent, so that's really x to the 0, but that looks super silly, so we just write the number. Now, what I circled in the beginning was degree of 2. That is the biggest exponent, so that's quadratic. Here, 5x, the biggest exponent, is a 1. That's the only exponent next to the x. Then degree 3, because the biggest exponent's a 3. And then a constant, the number by itself, because there's really a variable x with an exponent of 0. Now, slide number 4, you want to color code, and you want to look and see the biggest exponent. So here, the biggest exponent I have is negative 2x to the third, because the exponent's 3. There are no other exponents to the third. There's no x to the 3. If there was, we would combine them. Then we go down the line. We look at the exponent, x to the second power. I have another x to the second power, so now we can combine them. It says 7 minus 1, so that's a positive 6, and then x. Then we go down the line. We look at the exponent of 1, which is negative 6x, because x has an exponent of 1, and then positive 3x. Combine them to be negative 3x. And then we just look at the constants, the ones without the variable. 4 minus 9 would get you minus 5. Notice that it's in standard form. I made one big mistake that you have to be careful with. This is actually x squared, because all my reds are x squared. So I have a 3, a 2, and then exponent of 1, and then a constant. So they go down the line. Make sure that you double check your answer, and make sure it's the biggest exponent to the smallest. Now for number 5. Number 5 has this plus sign. When there's a plus sign, we just rewrite the whole problem. And then we combine it like slide 4. We want to look at the biggest exponent first. Biggest exponent is at 3x to the 6. There is no more x to the 6, so we're going to rewrite it. Then go down the line. We have x to the third, and we have another x to the third. We have 6 of them here. We have 4 here. 6 plus 4 is 10. Don't forget to write x to the third. Then we have a positive 4x minus 4x. They're both x to the first, so those are like terms, so then it's minus 3x. And then we have the constants, negative 6, and be careful, this was a positive 2. Negative 6 plus 2 is a negative 4. So you can always double check. Type it in the box. And then there you go. Slide number 6, same idea. You don't need the parentheses because it's a plus sign. There's a plus sign in the middle. Since there's a plus sign in the middle, we're just going to combine like terms. And the reason why we could ignore that, because a positive times a positive is itself. A positive 1 times negative 7x is itself. We don't have to distribute that because it's just a positive number. So that's why I'm telling you that you can just rewrite it. Look for the biggest exponent. 2x to the third doesn't combine with anything. Now 5x squared, it has another x squared over here. 5 plus 4 is 9, x squared. 3x minus 7x minus 4x. Notice I didn't switch colors. That's okay. I'm using a different shape. As long as I visualize what the work is, it's totally fine. 9 and then minus 6 is a plus 6. So as long as you have some type of work, whether you circle, box, use colors, squiggly lines, double lines, that's the work that we need to see. We need to see that you can group like terms together. Slide number 7 is a little different because of this negative sign. You want to distribute. Negative times a negative gets you a positive 3x squared. Negative times a negative gets you a positive x. Negative 1 times positive 2 gets you a negative 2. And remember, that's a 1 there, a negative 1. And then there's nothing in front of the first parenthesis. So I can rewrite it because there's nothing to distribute. And then you go and combine like terms. 4x squared plus 3x squared gives you 7x squared. Then the next biggest, negative 2x plus x gives you minus 1x. Or you could just write x. And then 3 minus 2 gives you a positive 1. Now, if you don't want to write that negative 1, you don't have to. It could just be a negative x. Either way would be fine. Check your answer. And then we can move on to slide number 8. So for slide number 8, all right, now we have this negative. Negative times a negative is a positive 3x to the third. Negative 1 times a positive, remember that's really a negative 1. Negative 1 times positive 2x squared is a minus 2x squared. Negative 1 times negative 8x is a positive 8x. And then all the way over, negative 1 times negative 8 is a positive 8. And then there's nothing to distribute, so that's why I was able to rewrite the first parenthesis without the parenthesis. So there's nothing in front, so I could just rewrite it. Start with the biggest exponent. We have 6x to the third. I have another x to the third. I have 3 of them. So 6 plus 3 is 9. X to the third. Then we have negative 2x squared. Nothing combines with it, so we can just rewrite it. Negative 7x plus 8x gives you that positive 1x, or just a positive x. And then negative 4 plus 8 gives you a positive 4. So you can check it. Make sure it's in standard form. Biggest exponent and descend, which is decreasing, all the way down. And we're good.